Hello everybody and welcome to a chat from the engineering desk. Today we're going to have another automotive chat, and it involves the reason why throttle bodies on gasoline engines are heated even though the fuel system is injection. So you've got a fuel injected gasoline engine and the throttle body has got hot water from the cooling system of the vehicle engine flowing through it. Why is that? So what we're going to do is draw on here together. I'll explain to you what's going on. So I'll start off with a square, like so. And that's going to be our throttle body. And make it square. So 100 millimeters. It's a very square throttle body. Now we need a hole through it. So that's where the air is going to flow through. So let's make this a big one. Let's make that an 80 millimeter throttle body. Let's pretend that we've got a 6 or an 8 cylinder engine here. Something with a bit of chooch. Now we need a hole. And there we go. So there we have our throttle body. Let's pretend that we have mounting holes as well. Let's add them in. Just for fun. Let's make those 6 millimeter bolts. Like so. And that one. And that one. Right, now we've got the bolt holes in the throttle body. And before we get too excited with about the rest of the stuff that's going on here, let's add the connections for hot water. So hot water would flow around the periphery of this thing. So let's make one there and one there. And let's add our pipes. Of course they need to be hollow. So let's do that. So that is 30 plus 50 of half of that. So let's do that. Maybe not that much. This is only for illustration anyway. So there's your hot water connections to your throttle body. And make them red. You can detach them. Make them red. Very good. Now I can see what's going on. Remember, this is illustration only, we're just having a bit of fun here. Now let's add the butterfly, which is going to live inside this opening. So what I'm going to do is select that plane, so we're going to have the shaft going through this side. So what we need is a throttle shaft. So let's add that in. And what I want to do is I want to draw that up here on this plane. Extend it that way. Extend it that way. So that's our throttle shaft. So if we were to fit that into the throttle body, it'll sit there like that. Okay. Now what we need is a butterfly. So I'm going to select this plane. Let's think about that. Yeah, that'll do. Let's do it like this. I'll click on that point. Create an 80mm disc. And what I'm going to do is give it a little bit of dimension and make it 2mm thick. It's a butterfly. Now we need to put it onto the throttle shaft. So I know that that's 10mm. So I need to move it 6mm across. Now let's do that. So it's going to look a little strange the way I'm doing it, but never mind. Let's have a look. And let's move the back. Right, we have a butterfly. So if we operate that butterfly, it's going to work like that. So let's put it more or less in a closed position. Let's install it in the throttle body. Now you can see it inside. So now with it inside the throttle body, you can see it opening and closing. Slightly offset. Let's see. Let's just move it across a little bit. I'll move it across by 1 millimeter. Yeah, there we go. Good enough anyway. So there's our throttle body with the hot water connections. Now what happens with the throttle plate that's partially closed is that you've got air coming in at atmospheric pressure going past this area over here. Let's hide that. Now what happens is over here the air expands as it flows through the throttle body. Now in the old days you'd have fuel present, but these days it's only air present. But you've still got a problem that your air now enters a region of low pressure. So adiabatic expansion takes place. So the air expands because it's now under low pressure and it cools. And if your air coming in from this side is already at a low enough temperature and contains a lot of moisture, you get ice forming over here at this point, and your throttle plate for one becomes stuck, but secondly the ice obstructs the airflow. So that's why you've got hot water in this body, which prevents the stuff getting cold enough for ice to form. So keeps it warm and you don't get ice. So that's why modern fuel injection systems still have hot water in the throttle body. On aircraft, the fuel has got no ethanol in it, unlike cars which can tolerate some ethanol in the fuel. F-gas is pure gasoline, there's no ethanol in it. And that's why you don't run aircraft on automotive gas, or what the aviation people call MOGAS, is because of the ethanol, which causes carburetor icing. So there's our throttle body in its entirety, an illustration. So don't be surprised if you happen to be looking at a vehicle throttle body and you discover that there's hot water connected to it, or you hear mention of the fact that there's hot water hoses on the throttle body. It's for this reason that they have that. Let's get rid of that. Let's do that. I just want to delete those detach, hide, a little bit of playing with CAD in this talk as well. Never mind. Let's play with this throttle a little bit. So I'm going to select it. I'm going to select rotate. And there you can see our throttle butterfly moves inside a throttle body. Let's give you the top view. It looks like that. What is there to talk about otherwise? These throttle plates are often these days worked by an electric motor as well. So there's a little brush motor with a gearbox and some feedback pots and stuff on it, working on it with a drive-by-wire systems that we have these days on the throttle bodies. So this shaft we connected to a gearbox and a little DC motor that drives it. And the ECU's got an H bridge in it, which supplies current to the armature to work the motor that moves this. That's the long and the short of why automotive throttle bodies have got hot water in them. It's because otherwise you have ice and then the thing doesn't work properly. Hope it was interesting. Hope you learned something. Hope to see you here for more. For the rest, have a wonderful day further. Cheers, folks.